लीजिए people, I have to tell you about the like we are on to the binomial distribution, by the way. Okay, and we were we have seen that if there is a binomial distribution with the parameters n and p, so we can find the probability x equal to r through the formula ncr, and this is p raised to power r, and this is q raised to power n minus r. Okay, Acha. I have to add two formulas into it, and I tell you that uh, like when you were when you started your O-level statistics, there you have seen that when you have raw data, there you find the mean through the formula sigma x over n, and later you saw that there is also a formula for the variance that is going to be sigma x square over n minus this mean square. And then you guys studied the frequency distribution. In the frequency distribution or the grouped frequency distribution, the formulas were like the mean was now sigma fx over sigma f, and similarly the variance was sigma fx squared over sigma f, and then minus mean squared. Then you have done the probability distribution. Okay, in your probability distribution, you have seen that there was a new name for this mean that was E of x, and it was sigma x into the probability x equal to x. And then there was a formula for the variance of x that was sigma x squared into the probability x equal to x and minus this mu or E of x squared. Okay, this E of x is also called the mu. Now, when you're studying this binomial distribution, you should know, okay, how to find the E of x and how to find the variance. But there are very simple formulas. The E of x over here, or this mu, is going to be NP. Just note it down. This is beyond the scope of your syllabus to tell you that why this is NP. Just note it down that the formula for the mean is going to be NP, and the formula for the variance of this binomial distribution, that would be NP cubed. And here, if you change this q with 1 minus p, you know that this q is 1 minus p. The same formula for the variance also becomes np minus np squared. Okay, I give you time to note it down. Okay, so if you have noted down the formulas, then we can move on to the exercise. Okay, now it says here that look at this exercise 7b, and you will have a test from the 7b and 7a on Monday, inshallah. Okay, so it says calculate the expectation. So it's talking about the mu, or that is the E of x. Okay, that is expectation is a new name for the mean in your probability, and the variance and standard deviation of each of the following discrete random variables. Okay, so let's make some space for the working here, and then I'll find some questions, and then we will try the rest. Okay, so this 1a, you have v is binomially distributed with n as 5, and this is your p, which is 0.2. Okay, so guys, your n is 5 here, your p is 0.2, and your q is 0.8. When it says find the expectation, so we have to find E of v, so that is going to be np. So this is going to be 5 times 0.2, and that is equal to 1. Okay, and then you have the variance of this v, so that is np cubed. Okay, this is 1 times 0.8, so this is 0.8. And when you have the standard deviation of this, so that is going to be I can use this s square for this uh, variance. So this s is going to be the square root of the variance. So that is the square root of 0.8. That is the variance, I mean the standard deviation of this distribution V over here. Okay. And this way you can try some parts from this first question. Now look at this second question. Now, if you have started this, it says x is binomially distributed with this n as 8 and this p is 0.25. So your n is 8, your p is 0.25, and your q is 0.75. So you can find this e of x, that is np, 8 into 0.25, that is I think 2. And then you have the variance of x, that is npq. So that is 8 into 0.25 into 0.75. Okay, so I think that is going to be 1.5. Yes, Bacho? That is a variance.
Yes,
Anna? Acha,
yes,
now
sir.
look at this B part. It says uh, find the probability in this B part. It says find the probability that your x is equal to E of x. So he's indirectly asking you to find the probability that your x is equal to 2. Okay, whenever he uses such thing. So you know you have already calculated this E of x. So that is going to be 2 over here. So this would be uh, 8c2 and your 0.25 raised to power 2 times 0.75 raised to power 6. You're already familiar with this, है ना? And then you look at the C part, bacho. The C part says, find the probability that your x is less than E of x. Okay. So this is exactly same as probability that your x is less than 2. Your x is less than 2. ठीक है ना? Because your E of x is basically 2. So then you will simply say, okay, this would mean that you have to find probability x equal to 0 plus the probability x equal to 1. Okay? And then you do it like this is 8c0, this is 0.25 raised per 0 and 0.75 raised per 1 plus 8c1, this is 0.25 raised per 1 and 0.75 raised to power 7. Okay? And then you will use your calculator. You can take the screenshot quickly and then I can move on to the next part of this exercise. Okay, now if you look at this question number 4, yeah, question number 4. In this question number 4, it says that he's asking you to find, let me space here. Okay, look at this question number 4, Bacho. I believe you can do it yourself. It says x is binomially distributed with the parameters n and p. And now you're given E of x, which is 20, and you're given the variance of x, Bacho, which is 12 over here, okay, which is 12. So he's saying find the value of n and p. So, you know, this E of x, you will change that with np, that is going to be 20. And this variance, that means 2, that is npq, that is equal to 12, okay. From this, you put np into this. So can I say this is going to be 20 times q, that is equal to 12? Anna, this is
Yes,
12 over 20. So that is 0.6. And then I know that your q is q1 minus q, that is your p. So this is going to be 0.4. And you put this p over here. This is n into 0.4. That is equal to 20. So your n is going to be 20 over zero point 0.4. Okay. So I think that is going to be 50. Anna? So this means your n is 50 and your p is zero point 0.4. Remember, Bacho, whenever you're finding this n, this n should always be a whole number, a positive whole number, a positive integer. This cannot be in a decimal. This p has to be, p should always be between 0 and 1. Okay, like this. Okay, this p cannot, this is a probability, so this cannot be more than 1, or this cannot be a negative value. Okay, and similarly your q is also between 0 and 1. Okay, so just remember these things. Acha, so this way, you can, like, you can try this question again. Okay, just to be sure about how to use these formulas. um, there is one thing over here that I want you able to try. Look at this question. It says W has a binomial distribution where E of W is this, and then he's asking you guys to, you see, he's asking for the probability distribution over here, the probability distribution table. Remember the um, what was that in your previous chapter you have seen that how to write down the, how to draw the probability distribution, है ना? So we're going to do the same over here. Let's do this question. You have this E of W, that is 2.7, and you have the variance of W, that is 0.27. So again, we're not given that if this W is binomially distributed, then what is this N and what is this P? So let's find that first. I'll change this with NP, and that is going to be 2.7, and this is your NPQ, the variance, that is 0.27. Okay, let's put this NP over here as 2.7, and you get your Q from here. So it's 0.27 over 2.7. That is going to be 0.1. Yes. And this will give you P as 0.9. And this will give you your N. This NP was equal to 2.7. So this 0.9 n is equal to 2.7, and your n is going to be 3. N is going to be 3. ठीक है, are you clear up to this, बच्चों? Is there any question? Hello, hello, hello.
No, sir.
No, sir.
No, sir.
Okay, okay, that's great. Now let's see how to write down the probability distribution here. Now the probability distribution is, now this W is, suppose we are doing something for 3 times. There are 3 trials. How many times this W can happen out of these 3 trials? Like suppose if you are tossing a coin 3 times and you're looking at the number of heads. So what is the possible number of heads? There are 3 tosses. What are the possible number of
0 to
heads?
3.
Exactly.
0 to 3.
Very good, beta. So it's going to be 0, 1, 2, 3. I'm giving some space because you will just find out here. So since this is binomial distribution, we can easily write it here. And this is going to be, you can do this in your rough work as well and just write the probability here. But I just want to show that your P is 0.9 raised to power 0, 0.1 raised to power 3. Someone please use the calculator and tell me at least up to 4 decimal places. The next one is 3C1, 0.9 raised to power 1, 0.1 raised to power 2. Please use the calculators and tell me what are these values. This is 3C.
Sir, the first one is 1 into 10 power minus 3 exact.
That is going to be 0.001. Okay, is that so? Yeah. Okay.
Yes.
Okay. So this
So
one
the
is
second one is 0.027.
0.027. Okay. This is 0.9 squared into 0.1 raised to power 1. Okay. And the last one is going to be 3C3, that is 0.9 raised to power 3 and zero point 0.1 raised to power 0. So what do you
So
have
the
here?
second last one is 0.243 exact.
Okay. And this one, this is 0.729, I think.
Yes, sir, 0.729.
But you tell me, what should be the sum of all of these four probabilities?
One.
Yeah,
One.
this should be 1. Okay. So I had to tell you up to this. I have given you the formulas for um, the E of X and for the variance of X. This way, this binomial distribution segment is completed now, bachcho. Okay. Inshallah, in our next class, we'll be studying about the geometric distribution. Now, this is totally up to you how much you practice this. Okay. So that is it from this binomial distribution.